Hey, what's going on, everybody? Today is June 4th, and you are listening and watching to the Daily AI Show Live, your source for the latest insights on how artificial intelligence is transforming our work, our play, and our world. My co hosts are Junmi, Andy, Robert, and I am Beth. And today we're tackling one of the most pressing challenges facing the AI revolution, and it's its immense energy footprint, and that is not talked about enough, which is why we are talking about it today. AI unlocks incredible breakthroughs across industries, from healthcare to finance to transportation, but this progress comes at a cost. The staggering amount of electricity, like literally the giant amount of electricity needed to power all the algorithms and the data crunching and the data centers, and more data centers are springing up as the need to have more more usage is coming up. Consider this: a single query to ChatGPT consumes 10 times more energy than a typical Google search. I'm going to say that again. A single query to ChatGPT consumes 10 times more energy than a typical Google search. So if you scale that up to the 180 million users and counting, because we know that we're at the very beginning, and the amount of usage that it will be having in the next year, 2 years, 5 years is going to grow exponentially. You can see how the AI boom is putting unprecedented strain on our already aging power grid. In fact, data centers alone are projected to consume 20% of total US electricity by 2030. Again, 20% of US electricity by 2030. So the carbon footprint of this is also really concerning. Typically, natural gas is being considered as the bridge fuel to get to power to give us the electricity we need, but natural gas is not a carbon neutral um, uh, energy source. Therefore, and Microsoft, Amazon, and Google are making major strides to power their AI with 100% renewable energy. Now, Microsoft has committed to this for 2025, 100% will be from renewable energy. Amazon has also committed for 2025 and 100%, but it seems like that's a little more complicated. And Google is shooting for 2030. So, our question today is the AI industry doing enough, fast enough to mitigate growing carbon footprint and handling the exponential need for more energy? Or are we seeing lip service and greenwashing? Andy, do you want to kick us off?
Sure. Thank you. So I'm gonna reference Jensen Huang, the CEO of NVIDIA. NVIDIA is at the center of the compute process that is used to consume all that electricity. And he has put out a thesis, which is that we're in the midst of another industrial revolution where data centers are the factories, the new factories that are generating tokens. And so all of our interest in reducing energy is being offset by the emergence of these many, many data centers to provide the compute that is necessary to provide the AI capabilities to the larger population of the globe. So data centers are definitely contributing to this issue. And what you get as an image of the Industrial Revolution analogy is, okay, now here's the factories belching, polluting smoke. In this case, it's a step removed from the very quiet and clean, but very hot data centers that have to be cooled with enormous electrical consumption. Those are actually somewhere else being generated. Like, let's take in China, coal is the main generation source for electrical energy in China. So, there's a chain of supply here that's actually generating more pollution, more greenhouse gases, and so on to support this multiplication of the cost in electricity of making AI accessible to us all. So let's think about the statistic that Beth put forward, which is that a single AI query costs 10 times what a typical Google search would. But now think about Google and their data centers. They're doing the regular Google search and they're doing the AI inference. So obviously, this growth is really challenging. We're multiplying the amount of energy consumption that's associated with this. Now, there's some hopeful progression on the side of chip development. Like all of the new, by the way, so we've got data centers, and then you've got the whole emergence of Microsoft Copilot Plus PCs. So Copilot Plus PCs are adding additional processors to laptops and PCs, which will make local or edge inference possible. So you can get AI capabilities right on your desktop. But that's also implying some additional power consumption in your own home or where computers are being used in the workplace. So how do we mitigate that? Well, the chip manufacturers are all really intensely focused on reducing the power consumption of those chips. So just in the last couple of days, AMD announced a new NPU for their Copilot Plus PC line. It's called the AMD XDNA2, and it has double the efficiency of their prior generation of NPUs. They accomplish this by reducing the space between the layers in the chip and so on. But then Intel is also pursuing the Microsoft Plus PC world and trying to reduce the power consumption of their chips. And their new Lunar Lake AI chip is 40% more efficient. So it's an improvement, but not quite the doubling of efficiency that AMD is claiming. And then finally, I'm going to mention that in the long run, like let's say the 10-year time frame, there will be other changes to the architecture of the overall machine that is delivering AI capabilities to you. And one of them is that the current architecture of deep neural networks, which is called multi-layer perceptron, which is a bunch of hidden layers through which all of the tokens have to pass, that's inherently less efficient than some alternative methods. And one that's gaining some attention on the news front in AI right now is a Kolmogorov-Arnold network architecture, which is inherently more efficient than the deep neural network based on multi-layer perceptrons. It's significantly more efficient, like a tenth the power consumption required for inference, and more precise in many ways. So there will be changes and advancements both on the chip side and on the software side where it's running. And then finally, just to kind of round out my commentary on this one, there's also an experiment underway in research called Neural Platform, which uses living brain cells as part of a hybrid electronic plus wetware computing infrastructure. And when you use brain cells instead of silicon chips, you get the same kind of compute result with a living system, living in the sense that those cells are alive, but there's no consciousness involved in there. But hey, maybe artificial general intelligence will happen on a neural platform before it does in a silicon chip. But that takes 1/1,000,000th of the power requirement of silicon chips. Okay, so scary right at the moment because all of this energy consumption in AI, but lots of different fronts for the advancement of the technology that will reduce that in the 10-year time frame.
So did anyone else have like movie images flash through their head as like, yeah, no, we just need to hit the computers up?
I had a bunker that I want to build now for the coming apocalypse when they take over our. Dude, you shouldn't have done that. My brain is going on a rabbit trail, Andy. That's scary.
Well, it was a wild story because it's not only is it a matter of they're using these vat-grown cells. They're even it even comes with a certain form of vision, right, on top of it. Dude. So it has sensor organs as well. So
stop it! I don't even want to pretend.
It's a slightly different rabbit hole.
Because their stem cells are anyway. I want to go on a pivot. Not that I'm going off topic, but I think it's on topic, but different because we're talking about energy costs. But I was at a conference one time and the speaker was talking about this, and he was a very smart guy. Actually, it was, come on, he was some bigwig, head of something. Anyway, oh yeah, he was he was head of Oak Ridge National Lab. So I was at the University of Tennessee, and he was speaking about models and AI and whatnot and energy costs. And I mentioned that you didn't talk about water. That the amount of water usage is absolutely ridiculous because of the cooling needed to cool these server farms or these data centers. Here's a few ones for you. Training a single AI model like GB3 or 4 requires 700,000 liters of water. A simple conversation with ChatGPT consisting of 20 to 50 questions can use up to a 500 milliliter bottle of fresh water. So that doesn't seem like very much, but you're not doing it's inference. You're just asking a couple of questions. You think that's not a big deal, right? But it uses a lot of water. So I think that is something that a lot of people aren't aware of as well. In this conversation of energy costs, we definitely need to be talking about the amount of water being used because not that it's a finite resource, but it is it does affect those in the community. So what do y'all think about that?
Yeah.
Oh, go ahead, Sarge.
Microsoft actually is exploring underwater data centers for that reason, because it's an easier cooling process. But of course, our oceans are also heating up. So there's lots of levels of that. But I agree, Robert. It's a totally adjacent concept. Jimmy, what were you going to say?
Well, Robert brings up a great point. It's not just our electricity costs and that direct energy production and use. That's a question. It's a larger environmental question as well. Mm-hmm. So besides energy, besides water, there's also where they're being built, how they're being built, and then the infrastructure for those energy needs, even if it is renewable energy. Lots of renewable energy or EV systems and things like that require mining of cobalt and lithium, and those are all finite resources. So I think this is just a more holistic look at what are the full costs of, and not just AI, it's going to be any massively adopted technology like AI, right? We came across similar concerns, environmental concerns when blockchain and cryptocurrency was introduced. We see that now when we're looking at air travel, which is still, I believe, the number one CO2 producer and things like that. So I think that AI is another component of the larger energy and renewable or sustainable environmental package as a whole. Long term, what are the things that we can do to support or at least offset what these new technologies and infrastructure is going to cost us? I think that's the level of approach that we have to take, not just, let's solve this one thing. I think solving a larger infrastructure issue would help alleviate across the board.
And I will say, and Carlos, if you need to jump in, I'm sorry. I want to say one thing that, there's a new model that came out recently, Zamba, and, it's like a hybrid transformer model. And I think this is the truth of the electric vehicle kind of network. I was in a Uber one time with this very green Uber driver who spends 3 months of the year doing Uber in the United States, and then the rest of the year at his house in the Costa Rica on some kind of plantation. Like he's like I always say a new version of a hippie, and he's a really nice guy. And he was like, live off the land, but I need a little bit of money. So I come up here and do Uber for a little bit and go back home. And we were having this conversation. And I was like, I don't think electric cars are the future because the power grid can't handle it. And he's like, oh, don't worry. The scientists will handle that problem. And his whole thinking was the batteries are going to get more efficient. They're going to get smaller. They're going to get easier. All these things are going to happen just by the nature of scaling laws. Right. And so Zamba is an example of that. It uses a lot less tokens. Everything is going to get better, quicker, faster, easier, smaller, by the nature. So, I mean, I'm not trying to, punt this conversation, but I do think that there is mechanisms in place, and there's definitely some motivations from these companies to improve the tech, for all the reasons, mostly because of the energy cost, because it is cost money, not just that the green footprint. So they're motivated by money more than anything else, and then making it more profitable for their business model. So I think those motivations will continue to make the models less power hungry and less water hungry, hopefully. Carl, were you gonna jump in?
Yeah, I'm curious to see how the energy consumption as we move into agentic features in cars, businesses, and they use more and more of it, because we see that we just talk about how LLMs are trained, data inference, and so on. But as more and more companies start attaching, rebuilding, using AI, what does that mean for, I guess, our business or other businesses and local businesses? Now, I don't know if there's any research done on that, but there'll just be more and more usage. Or is it more of where instead of using local compute, now it's AI? Or I'm just not sure, because as we transition a little bit, what does that mean? What does that, like, I feel like we're just going to be using more and more of it, and you're going to be using more and more in your vehicles. Does that consume a lot more energy? If you're powering a lot of the, or is it the same? I'm really not sure. So that's just one thought
Right.
I had as we progress.
And the kicker in this thought is that these are projections. So there isn't actual research, because we don't have really easy agents to use, right? We don't have the scenarios, but we are seeing that month over month, the usage of AI is increasing now at a fairly small rate, at least from our standpoint, right? That's sort of slow, but it's still a continual increase. Right. And the real question here, I think, is the pace of innovation going to be able to keep up with the pace of adoption? Because if adoption grows higher, then innovation lowers the cost or lowers the effects of the energy that we're using. We're still in a hole. We're in a ever deepening, digging ourselves further into a hole.
Well, I think this is a great use case for AI.
Yes.
The hope is,
good point.
We have these super knowledgeable, all the knowledge in the universe kind of things. And we've seen AI applied to things like finding protein molecule combinations and using in medical science and things like that to find different new pharmaceuticals, finding early detection of diseases and things like that. This is one more application of AI. I want to see who's building the energy efficiency and energy grid or energy needs fine-tuned model. We've already talked about in the past that there's those 50 U.S. companies that are concentrated on solving various issues in business and in the world, and particularly logistics. This seems to be like a logistics issue that these kinds of AIs can be built towards. So, hey, let's have AI solve the problem that we haven't been able to solve yet. Maybe. I don't know.
Well, aren't we? Hasn't all these companies started talking about building new data centers? So one would assume that they would start thinking about, hey, what is the energy consumption of said data centers? Can we make it more energy efficient? What is the cooling looking like? What is it being powered by? Solar. I don't know where you're building it versus, I wouldn't build it up in Canada because, well, maybe in certain places because it gets cold. Like, do you maybe build it in places like where there's a lot of wind, where there's a lot of sun, so it would be powered there? I'm positive.
Cold is good. for computers.
That's
Computers
right.
like
You, you want to
Right.
build? Okay, well then why don't? Yeah, you could definitely build it up. A little plug for the folks in Nunavut or the folks in the Yukon. They would love having data
right,
centers up there.
right. Well, one that actually brings up an interesting point, and one of the challenges for building out a better energy grid, or is the transmission and integration of these energy sources now, whether they be wind or solar or whatnot, into the existing grid, right? Because our grid is very fragmented for the most part, and always could use better upgrades and things like that. By if we take, for example, like what we were talking about, is if you build the data center in the cold place, but you improve the transmission connection, then you can have your wind and solar in the geographical areas that it would be most efficient in, right? And it's that transmission, getting it from A to B, which could see lots of improvement. And I think this goes back to the logistics question, right? If we can solve for the most efficient transmission of the energy, if we can solve for the logistics of getting everything from point A to point B in the most efficient manner, then we can see lots of savings, whether they be cost savings, whether they be energy savings, whether they be time savings, and all of these cumulatively will add to an overall better result.
So one of the things that I think is happening in this context is, because we are so removed just in our modern life, at least, okay, so I'm speaking from a position of privilege. I will admit that I am very removed from the source of what I consume. Right. So when I turn on my tap, I don't understand the infrastructure or where it's sourced or how that's getting to me and the energy that that's using. I know that, I know the basics, like bottled water is bad for a variety of reasons. So we should try to be more, we should try to like reduce the waste of our things. Same for energy, right? Like I turn on a light switch, I understand some of the wiring, but I don't understand how it attaches to the grid or how that grid is powered in my area. Again, I have sort of top level knowledge, but I feel like the more removed we are from these questions, the more we then turn to, well, the people who are really into this will solve it. Right? The scientists and the engineers and the techs that I don't understand, but I trust are, like benevolent fairies out there solving all the problems. I am not sure that
You
is
know,
true.
I have to commend you. That's a very interesting perspective, and kind of speaks to the naivete of us in this Western world, and we kind of live on this level of consumption, and we don't think about what it takes to consume. Case in point, California recently have started to tax miles. So they're trying a program because there's so many EVs that the gas tax that they rely on for road maintenance is
Oh,
not
wow.
enough to cover the cost of road maintenance. So all these EV vehicles have backfired sorta on one element of the infrastructure of the government. And so now they're beta testing charging people for the miles driven. Much like a toll booth, but less bottlenecky as a toll booth is. And so I'm like, that's a prime example. They thought they were saving the planet, or maybe reducing on, which they did. They did save on the pollution for places like LA, but now there's other elements of that they weren't aware of. Like there's people, they need money to solve the problems of the road maintenance. So it's definitely something that we need to be aware of, I think, in general.
Very interesting. Yeah. So I want to go back to Google, because Google and the like, all the people like Amazon and Google and Microsoft and Facebook that operate data centers, they're public corporations that are at the forefront of trying to improve the efficiency of all of that operation against the onslaught of additional AI inference costs. But they already exist, and those data centers are serving us and the internet, which is central to our lives at this point. And we are going to be quite dependent on them to achieve what for example, Google is saying, which is that they plan to be arriving at all renewable energy sourcing for their data centers by 2030. That's not very many years away. But that's a major initiative internally and largely focused on ensuring that they have access to the power that they need and at the lowest cost. But to put it all in perspective, the annual electricity consumption of Amazon plus Google plus Microsoft plus Facebook data centers alone is close to the amount needed to power all US households. That's the scale of the issue that we're talking about here.
Yep.
Does it exponentially increase if I Google something to buy on Amazon that I use GPT to determine what product I wanted to buy?
That's right.
If I used all of them, I'm like a hog of water
Yes.
and electricity.
Yes.
I'm the problem.
I'm the problem. It's me.
I think the tough thing is, though, like when we talk about all of this, it's very hard for like people like just any of us or people who are in the AI space to just say, you know what, I'm going to stop using it. It's like it's an unreasonable thing to expect. So the question really, what we can only take care of our own household ways to mitigate our energy consumption, but outside of that, like there, it's either government or the private sector that's really going to make the biggest difference out of all of this. I don't think yes, there are people, there are organizations that will do their thing to try to get you to conserve or try to lobby, but in the end I think the big players are the companies and the government, and that's it. That's what's going to affect this. And I'm not sure United States government. I don't know that there's it's actually funny, but in terms of policy and regulation, do you notice that never comes up? Like the energy consumption, I think I hear about safety and I hear about progress, but you barely hear about energy consumption. But it is a pretty big. It's as big, I think, of the other two.
Yeah, I'm here thinking about whether the emergence of Copilot Plus PCs as a leading edge example of edge computing, where instead of relying on the network connection to the cloud service, which is accessing data centers, gets ultimately replaced in pursuit of energy efficiency by simply moving the capability down to really much more efficient local processing that instead of running these data centers humming all the time, those data centers are available, but they're not being used primarily for inference. All that inference is happening more locally and on very efficient processors. Maybe there's a change to the topology of our network out there that is currently heavily reliant on data centers and the cloud, and all of the transmission that's involved in moving data back and forth over the networks to get to the cloud. Instead, you can draw down data, you move it once, and now it's local, and all the inference is happening locally. Maybe that, I'm sure there's some scientists out there thinking about what has to change about the infrastructure of the cloud centric networks that we have today in order to be truly energy efficient in the future.
So if we go into models that are more local, because a lot of us are concerned about data privacy, right? So like, well, if you make requests in the cloud or you upload or you connect it to your data, we've signed privacy forms and all that, but sometimes we're just not sure. But if you can keep things local to your device, local to your computer, then I wouldn't know, like I'm not the expert at this, but wouldn't that decrease the cost of data usage because you're not pulling it from the cloud? It's all local. And because models are getting better, will there be
I'm
eventually?
wondering
Right.
if the stats that Beth started the podcast on today were based on, uh, attributing the inference with the total build cost of the LLM. So, like, I don't actually think it costs that much. Maybe I'm wrong, Beth. Because if you can put it on your PC, like you were saying, and inference a few prompts, how possibly can that be more than a Google search? I don't know. Maybe I'm wrong, but I think that's how they attributed it, didn't they, Beth? Or no?
I think that the attribution was yes, because it's also because right now it's all going back and forth on the cloud. There isn't a local I don't think there's enough local usage for that. And the stats about specifically Microsoft, Google, and AWS are about training models predominantly because that's the majority of that cost, and they're all doing that. Right. I mean, it's bundled in, but the majority of that cost, because the majority of the energy usage in AI is part of training.
By the way, that adds another little twist to this, which is today we have a whole race of multiple companies all doing very intensive training of their own frontier models and their own models even locally. And there's an idea that enterprises will actually want to have their own data center in effect in order to train their own model locally for corporate privacy and security issues. But um, there is also this concept of merging models. So once a model is trained, you don't really have to retrain it. You don't have to start new with a brand new model and go through all the energy cost of building a new model at the same level. You can just take an existing set of weights from a model and merge it with another one that has other capabilities. And with zero training cost, you have a very competent mixture of experts model in effect. So is there a progression that's going to happen here where we're spending a huge amount of money to train models now, but eventually they'll train each other on the edge, if you will, of the developments of intelligence rather than having to develop natural language processing and deep neural network every single time you want to offer a new service, you have to train a new model. That may be a thing of the past.
But remember what all of them are saying, or Sam Altman pretty much said, hey, we're not done. Like, these models are like, remember there was, I don't know what the rule is called, where like there's people saying that, oh, this could be the best the models are getting, which then there's other graphs that are like, no. The more we train, we just need more training data. The more GPUs and the more training data, the better it'll become. So which means every year, every single one of these major companies will be training bigger and bigger and bigger.
This suggests a really great idea. Wouldn't it be great if there were a benevolent company like, let's call them OpenAI, because it's going to be open source, and they spend all the money to train the most advanced models and then share them with the rest of the world so that we don't all have to be out there training our own models and be in competition at the expense of our ecology, let's say.
And because at some point we went through the looking glass and we are now in the fun house, that is Facebook, Meta, and Mistral, right? Like, I mean, like, we are the people who are committed to open source are not OpenAI. And I think that's the key, because what you said relies on the open source models, right? The open source models are the only ones that offer the weights, or for the most part, small models sometimes.
I think we can come to a conclusion in this discussion that open source is inherently more energy efficient than is closed source OpenAI.
Well, I do have one last bit of data to answer Robert's question. And there was a study done between Hugging Face, big open source model location, and Carnegie Mellon University. And they had worked out to essentially the average smartphone usage to charge was 0.012 kilowatt hours, right? And they compared that to written examples when you do an inference, when you make a request from a model, and that costs 0.047 kilowatt hours. So like 3+ times the amount to charge your cell phone, to give you a little bit of a ratio there. So inference, while not as much as initial training for foundations, still requires a huge amount of power.
Yeah.
Right. And if we think about that conversation that we had in the very beginning about the wetware that gives me the heebie-jeebies, what we're doing is we're moving things that humans do within a human energy system to an artificial intelligence that works with an electric energy system or a power sourced energy system. And so as we shift those functions from human to this other system, we as humans, our energy system is much more efficient than the ones that we've created in the world.
Evolution.
Yeah. Okay. So thanks so much for joining us. We have a newsletter and a website, and we would love it if you would go and sign up. That's the dailyaishow.com. We're also on our journey to 100 YouTube subscribers. So if you're engaging in this on YouTube, or even if you're not, we'd love it if you'd run over there and just hit subscribe.
It's 1,000.
Sorry, what did I say?
You said
1,000. Oh God, no.
You passed
1,000.
that long ago.
Sorry. Yeah. I'm saying too many words, and I do have a tendency to cut off a zero, and I'm very sorry for that. Yes, 1,000 YouTube subscribers. That's our milestone. We are just millimeters away from that. So if you could help us out, we'd really appreciate it. Tomorrow, we are talking about all the news that has happened in the last 7 days. On Thursday, we're talking about the 5 AI tools that are transforming our lives. We'd love to hear from you about the tools that are transforming your lives as well. And on Friday, we'll do our bi-weekly wrap-up show. What have we been talking about in the last 2 weeks, and what has changed? Because if anything is true about AI, what is true today may not be true tomorrow. So, or may need amendment tomorrow. Thanks, everybody. It's Tuesday. Have a great day.
Oh.